Right, well, good evening everybody, and welcome to OREF on Tour. This is where are we? October. It is October, isn't it? Yes, the October meeting, and here at Deerness Distillery, and thanks very much to Stuart for hosting us tonight. This OREF talk is one of a monthly series that we do, which is really looking at all energy-related topics, and this is going to be unusual in as much as it's looking at a different sort of topic, a different part of the energy picture, and we're really looking forward to seeing what's going on. Just saying that we think it was about 3 years ago, Stuart did a presentation to OREF, which was about things that could happen, had some ideas what he was going to do, and I get the feeling it's going to be a bit different tonight in as much as things are going on, which is really exciting. Happy, I don't know if you want to take questions as we go or questions at the end, any particular preferences?
We've got questions at the end, but if anyone's got any burning question halfway through or through the presentation, then
yep.
We can...
So if you want any questions partway through, then feel free to stick your hand up. And also for those online, I think we can take questions online, and Mike will voice them if the need arises, or put them up. I don't know what technical jiggery-pokery he's going to manage. So without any further ado, if everybody's settled, I'll hand over to Stuart. Thank you very much indeed.
Great, thanks Neil, and thanks everyone for coming. That's on, great, it's good start. So welcome to Deerness Distillery. So we're sitting in the new part of the expansion just now. So this was completed a year ago. We started the whole journey back in 2016 when we actually started with our gins, vodkas and liqueurs. And as we've added on our all the equipment and everything else that's gone in, our energy has gone up and up and up and up to where we are now. So we've got some very heavy loads next door, especially around our hot liquor tanks and things like that. So we're sort of sitting at about a 36 kilowatt load on there when that's on kitchens and things as well. So as Neil said, probably about 3 years ago, we were looking at various different technologies, wind, solar, biogas, and a few other things to do here at Deerness. So going back even further, my background is actually, I was a project director and engineer in the mining, oil and gas industry, nuclear industry and renewables, and did 3 big biogas plants, one in Sydney and 2 big ones for Lancashire County Council. We actually came across from Australia, which is where I'm from originally, and built some projects here. So I understand the biogas side of things, the feedstocks and things like that. So I was part of the design team, designed it, commissioned it, and then handed over to the client at the end as a turnkey project. This is obviously much smaller than the ones I did in those projects. They were sort of 4 megawatt digesters, but we've been looking very hard at this, but at a much, much smaller scale. So my presentation is just going to run through a little bit about what we're doing at the moment. Obviously this all comes down to financial at the end of the day, because without that you can't move forward. But with this type of technology, there's quite a few green grants around that we can hopefully leverage off once we're a bit further down the track in terms of our feedstock analysis and things like that. Being a distillery, we've got a lot of brewers' grains, which comes from here. We have a polytunnel outside, like most people do in Orkney nowadays, which we grow a lot of botanicals here on site for our gin process, but also now for our kitchen and cafe. We've got a new addition going outside, which is also a raised beds where we'll be growing different vegetables and things, again, to support the kitchen. Obviously at the back end of the kitchen, we've then got food scraps coming out the other way. So we've got the ability to use a mixture of our polytunnels, our brewers' grains, and also our waste. So to create a project from your own waste is quite a interesting project. And I'm just going to step through the presentation as we go. Is that one there? Yep. So that's the artist's impression of what we're sitting just now. The grey building on the far side is the original part of the building. Everything you can see that's white is the addition that we've added onto here at Deerness. And as I said, this area here has been built about a year ago, and this took about 10 months from start to finish to actually put this up. Being a project manager, project director in the construction industry, I was able to project manage these through very quickly. So a 10-month build was great, especially with the weather we had the last couple of years. So in terms of our CHP plant that we're looking at here at Deerness Distillery, so we're looking at a 40 kilowatt per hour system, which also produces hot water at the back end. But we're looking for something for base load. So obviously with wind, solar and various other things, very cyclic. It's not going to give us the base load that we need. Whereas a biogas plant, we can run that with the gas train and everything else to give us a base load power. Some of the places where we need the hot water, especially our mashing process, we've got our CIP cleaning. We're also looking at doing things like piping our polytunnel floors. So take up the floor, piping hot water into underneath the polytunnel, heats the ground up, extends our growing season. We can do the same thing outside as well. In terms of scale of the projects, so this is sort of some companies we're actually speaking to at the moment. So we're talking about sort of between 20 and 40 foot size shipping containers that holds all the gear. You can see this one on the left hand side here. It's got a membrane tank in there. Depending on the size we go for, that might be slightly bigger. And then actually a bit more of an outdoor tanks as well. You've got the ability with this, so during the evening when we are no longer working in here, the biogas is still producing biogas, so we can have a small containment for biogas, which we can then run through into our stills. Our stills next door, which you can have a look at afterwards, are gas heated, so we're currently on LPG on those. And we went for gas stills, so direct fired. The reason we went for gas stills is electric stills, very, very costly. So we did the cost estimate for the electrical stills, be in the order of about £150,000 a year to run those, versus about £35,000 in LPG, so gas bottles. But with a view that we could eventually substitute that with a bit of biogas in there as well. So we're running off our own methane, which has been scrubbed prior to. So on the right hand side, the picture that's just about to fire up is our mash tun just emptying out the grains. So as you can see, highlighted in yellow there, brewers' grains produce quite a high metre cubed of biogas compared to green waste, and then compared to farm manure, which is only about 20 to 80 cube. So the brewers' grains are a good source of, in terms of bang for your buck, in terms of what you put in. In terms of what we actually need to put in there, so our brewers' grains here, 1.4 to 1.8 tonnes per day fed into the front end of the machine. Our loads going into our grains probably just about a ton a day. So we've got enough yield to put into that. In terms of engine sizing that we've been looking at, so 50 kilowatt gen sets, 80% load, which gives a 40 kilowatt continuous. It's a bit annoying, that beeping noise, isn't it? But it's there for a reason, that one. James know all about this, wouldn't you? Can you hear me all right on the speaker there, Mike? Is it okay?
Sorry?
Is this all going okay?
I'm just going to try and give you a bit of PA here. Just keep talking.
Yeah. So obviously we're producing heat from our biogas plant, sounds better, and we're also then going to have to be recovering some of that the engine jackets, so we can actually recover some water off there, which would then be great for our process fluids. So as I said, we've got a hot liquor tank sitting out in next door, 36 kilowatt load, but if we can actually use some of that engine heat to put back into that tank, we're only heating up a very small bit or keeping it stable rather than trying to heat from ambient water temperature, which gets going to be much colder in the winter time, 10 degrees, right up to where we need sort of 75 degrees on our first waters. If we've got the hot water coming off a jacket there, that's already at that temperature, and all we're doing is maintaining it rather than putting in a massive load. So again, just trying to really sort of reduce our energy usage. We've also got exhaust heat. We're looking at that at the moment. That brings a bit more complications. You've got gas to water exchanges. Then you've also got flue gases in there as well. So you can have corrosion issues down the track. As I said, spare methane, which we could then potentially use in our copper stills. So we're just mucking around with some of the feedstock at the moment to get an analysis on that on a sort of test bed size. So doing a pilot plant, seeing how much biogas we can pull off, seeing what sort of crystalline structures we get out of that as well. So in my previous life, when I was doing big biogas plants, you've got this sort of mixed municipal waste. You've got very much different sort of feedstocks coming in, especially seasonal as well. Whereas for us, for a grain, it's quite sort of stable. We start adding in stuff from the polytunnels, that's very seasonal. The café scraps are pretty much the same most of the year round. You can end up with different crystalline structures coming out as leachate, which goes into the biogas plant, which can affect your flow. And down here, so we've got a sort of 8.12 meters cubed per hour on our burners for our gas stills. So we're just working out what we need in terms of volume, in terms of gas. Pros and cons, lots of these. So reliable off-grid electricity. Obviously we're going to have, if we have 40 kilowatts running at a base load, there's also a potential when we're not using that to put that back into the grid. Obviously that's a bone of contention now, as most of you probably know in the area here. There's potential to use battery backups as well. But the flexibility that gives us is, and obviously it's our waste effectively, so we can still put some of our base load to farmers. At the moment, all of our grain goes out to some of the local farmers here for their beef cattle. But with this system here, it would probably be like an 80% usage of our own grain in the biogas, 20% would still go off to the farmer. Got the ability then to also, if we need more feedstock, there's potential to touch base with other distilleries who've got extra feed, extra grain that we can take away as well. Energy security, so moving forward, this gives us a nice, reduce our dependence on fossil fuels and grid outages. We've still obviously got the main grid here, but we'll try and be sustainable on our own waste. Provides a bit of sustainable agricultural integration. So we've got hot water, rich nutrient digest, which supports our own botanicals and food. The digestion plant also produces about 1.2 tonnes per day of a rich fertiliser out the back end. So that can then be, again, put back in onto the land, back through to the farmers. Comes out quite almost like a black treacle when it comes out the back end, but it can be mixed then into permastores and various other things to put back onto the land. So there's about 1.2 tonne feed at the front end, and then you've got a continuous feed coming out the back end. So in terms of financial side of things, cost savings, obviously reduce our electricity immensely on site. Got the ability to export that back in, provided everything else falls into place in Orkney in terms of exports further down the track. For us, it also demonstrates sustainability and innovation. I know there's a big push with governments all over the world for businesses that to try and offset and trying to look at different ways of producing energy, and so it gives us a very nice IP here. The plan for the future here would be to have local grains grown on site and at various farms. And then also we're putting a small malt house on site here, so we have a 2-tonne batch malting plant, so we can malt local grains grown in Orkney, whether it be beer barley, small batches of barley. Because our load is very small, we can do a 10-tonne batch of barley off a farm that is at malting grade into our new malt house, which is a 2-tonne batch malter, so we can steep, germinate, kiln it. The kiln also has a smoker box on the side as well, exterior smoker box, so we can smoke that back in. And that's trying to incorporate all of that in with the biogas plant, so everything is off-grid. Grants and subsidies. So I missed, unfortunately, when we were building this, I missed a great grant that came up, and So we're hanging around looking to see what pops up. Obviously, there's a bit of a turmoil in the government just at the moment, so we'll see what pops out in terms of funding to help us get going with this. Obviously, operational processes advantages, continuous supply of heat and power, reduces our energy volatility, integrates our heat and power in the management, we've got nutrient recovery. As I said, the fertilizer then, which we can then put back into our polytunnels, into our kitchen garden we're putting in next door, and also back out to farmers. And probably could be a nice little test site for colleges and universities to come and see, what we're doing here once we get this going, and gives us resilience as well. Lots of technical and operational challenges, having operated these but at a much bigger scale, and I've had many a time lying in the leachate trying to unblock pipes and things like that. So again, it's quite not a new technology, but there's at a smaller scale there's some complexities to it, and also obviously containing this sort of gas quality, so in terms of calorific value. But with the biogas, with the brewer's grains, we've got quite a stable feedstock there, so there's not a huge fluctuation in that feed. There are a couple of other breweries across and distilleries across Scotland and the UK that are actually doing this, and obviously you need someone there feeding that through the day, and you'll need someone maintaining that through the day as well. So obviously the cons on some of those things, obviously the financial side of things. So some of our initial costs, you're looking at about £150,000 just for some of the kit at a 40 kilowatt level, which sounds like a lot of money up front. Obviously then you've got to pipe the whole thing, you've got to put the infrastructure in, you've got to go through planning, building control, everything else that goes in place. I've had initial discussions with SEPA and obviously waste management licenses, and at this sort of scale you're actually starting to fall below some of the higher regulatory requirements in terms of emissions. We actually fall completely underneath the waste management side of things because we're using our own waste, and it's slightly underneath that. And the capital cost side of things, so payback period. So if you think about a wind turbine, what's a 5 kilowatt wind turbine nowadays? 30,000, 40,000 pounds. So if you start adding those up to get to 40 kilowatts, you're probably in the same ballpark, not too far away. And you get quite a lot of out the back end in terms of hot water and things like that as well. So you get a lot of differences from that. Obviously, it's feedstock dependence. So if we stop producing, a breakdown in the plant here, then we haven't got the feedstock to go in there. And that's something we're looking at with some of our local farmers here. There's quite a few farmers who've got old grain from last year sat in the back corner of the shed that sprouted. So there's things we can utilise other feedstocks as well. And also probably a discussion with some of the other distilleries, breweries on the island here, that we could take some stuff for them as well. Regulatory and safety challenges. Obviously, we're talking about gases, biogas, explosion proof. I've had initial discussions with planning departments in Orkney, which has been just on the initial side of things of what we want to do. So far, they've been on board with what we're saying. As I said, explosions. Health and odour management is another one. So with some of the projects we did previously, we had our exhaust emissions going through a bed of coconut husks as a abatement for emissions and odour. But at this sort of size, you've actually quite a small emissions. Obviously, noise is another one. So you've got an engine or a gas turbine running in the background. But again, there's ways to mitigate the noise production there. Obviously, we're quite remote where we are here, although on a high windy day you can hear lots of things happening in the parish. So operational limitations, obviously you've got lots of equipment, scalability and infrastructure. Being on an island obviously limits a lot of that, so you've got various bits of kit that are bespoke to the equipment, so having good spares, having a supply chain for that. We're also dependent on the continuous operation, so CIP units be running continuously, and if we go down, obviously it reduces efficiency in terms of the gas rebuilding again. So we're just working out our whole mass balance at the moment in terms of an operational CIP plant. Having a separate gas storage system for the stills, which are on Monday to Friday. With this on, we're able to go Saturdays and Sundays as well. Space requirements, not an issue for where we are here. We've got quite a bit of land here. We're probably tucking it in the back out of the way so no one can see it. And so digestion management impacts. So obviously you've got potential for pollution risks in terms of leaks. So we'd have to look at bunding the site. Look at all of our drainage and everything else. Obviously high rainfall with the potential for things to flood and leak out. And then the noise emissions. And obviously community concerns. A lot of people won't have seen a biogas plant in operation. And there'll be some concerns about the safety, about noise, about odour and things like that. So there's a bit of a community piece on this as well. But it's quite you can scale these to quite a small or a slightly bigger level, which would be great for smaller communities, especially in remote places. As you saw at the start, these are in shipping containers, so in terms of mobilising to site, all the engine and turbines, everything is all in one. CIP unit, it's got a PLC system, so it's all integrated so you can drop things on site quite quickly, start loading up the front end, and then start operating. So a little bit at the end, just some questions really. So sort of scuttle through that pretty quickly, but let you watch a video first. You dance if you want. Any questions?
That was very loud. That was brilliant. Can you just clarify exactly what stage you're at in the journey? Are you at the stage where the is it an AD plant or the biogas plant is designed but not installed? There were times when you talked about it in the future tense, but there's a lot of, obviously you're well advanced on it. Can you just explain exactly where you are on that journey?
In my head, I'm probably further forward than I actually am. So we are at the phase where we've basically, obviously, grain's only been introduced probably September, October last year. Been through lots of various sign-offs in terms of HMRC and various verification for Scottish Whisky Association and stuff. So we've only now got samples away to get analysis done on our, we put some figures up there of what our meters Q were going to be. So we're actually working out the mass balance from basic, taking some of our scraps as well to build that up, to build a mass balance to then take it to the next sort of costing side of things. As I said, I've had initial discussions with planning, SAPER and various other people like that. So there's a regulatory side of things, which can be the longer period in terms of getting the project going. We have been off to see a couple of the vendors that we're looking at a smaller scale. So there are a couple of companies in the UK that do it. There's obviously lots in places like China and other countries as well, but which brings a different risk. Having done a lot of work in China, I know where some of those pitfalls can be. We'd like to work, if we can do, with a European or a British, obviously with my background in terms of design and construction on these projects. So when we built these projects, there wasn't anything that existed at the time. So we utilised a lot of equipment, different parties, with a German inventor, Italian, and created a 4 megawatt system using municipal waste, green waste and things like that. So yeah, we're probably, and then obviously we've got to get some funding in place as well. So we're probably a good year and a half away, if not 2, before something here is on site. But yeah.
Thanks. Thanks for the talk. It's really interesting. Just for clarity for me, am I right that the stills are gas heated and that's separate from the CHP that you're talking about?
They are, yeah. They're separate from the CHP, but there's potential then to use excess gas. So in the evening when obviously the whole place is shut down, everyone's in bed, it's still producing gas. Excuse me. So we can utilise that gas, or some of that gas, into a secondary tank. Yep. So when you come in the next day, those stills can be fired up.
That makes sense. So you split your gas supply between the two.
Yeah.
And the other thing I wanted to ask, and I appreciate you won't know this precisely yet, but do you have a feel for what sort of proportion of your overall energy demand you'll be able to cover from your own wastes?
Yeah, so at the moment, obviously we've got various smart meters now in the new system, so we're sort of getting together a bit of a trend of where we're sitting. Summertime we're using more. Obviously got more tourists, more guests, more not so much lights on as well, because and again next door with the whiskey production, as that's ramped up now, we're at full capacity now, which sounds like amazing, but it's about 4 casks a week. Compared to Highland Park and Scapa, that's not very much, but it's about 1,000 to 1,200 litres of spirit a week is what we're producing. But obviously, as some of you know here, the energy demand of what you actually start off with, so we start off with 10,000 litres of fermentation. By the time that's gone through, you end up with about 1,200 litres, 1,500 litres, 10% of what we put in the front door. So a lot of energy goes in for a little bit out the back end. So we're just correlating what that load looks like.
So we're not sure yet whether you'll be able to cover 20% of your energy needs or 30% or anything like that? Yeah,
so at the moment, just looking at our figures, so a 40 kilowatt system would almost take us off grid completely, right, on our load per hour.
Wow.
So we'd be fully off. If we added in the malting house, obviously it's got air sparger system in there, so you've got quite a big load on the air spargers to dry the kiln, dry the grain once it's been kilned. That operates like a big washing machine, double tumble dryer, steeps, germinates, and it's got air spargers that dry that. But again, that could be done in an evening rather than the daytime, so we can sort of change our operational needs to suit the base load. When the kitchen's going in there, the 2 cookers are 10 kilowatts each, and then fryers, extraction systems, ventilation systems, they all sort of add on to the whole thing. But at the moment, with everything going during the day, which we have been quite regularly now, we're sitting, below that 40 kilowatt load that we're looking at. Obviously, as we move forward, that might be a 50 kilowatt system rather than a 40, as we've outlined there. The exciting thing for me is also the water that comes out the back end. So there's a lot of hot water there, which we need a lot of that as well, the processed water. So using that hot water at the back end to keep our fluids at a higher temperature. We've got things like after we've fermented, we've got to transfer into our stills, and they're coming from the stills, from the fermentation at 20 degrees. We've then got to heat that up, which takes a lot of gas to get to that point. But if we had a secondary tank that had hot water jackets going around that, so that liquid's preheated overnight prior to going to the stills, so our heating point's this big rather than this big. Yeah. So it's all looking at all of those sort of energy efficiencies.
Thanks a lot. Cheers.
I'm just going to voice a question we've had, or a comment we've had in from Jordan over there, who's online, so which is a really useful one. So thanks, Stuart. Really enjoyed the presentation. Keen to discuss funding opportunities with you, as I think what you are planning to do is a really good fit with the Ireland Centre for Net Zero demonstration zone that he oversees. So we'll make sure we link you up with Jordan after this. So hopefully there might be something that can help there. There's another question.
It was actually, I could segue in from that last point, which is the hot water system. Using the hot water in something like your polytunnels, polygrobs out here to do things like tomato growing or vertical farming beyond that to extend the growing season in Orkney might be a good opportunity. Have you thought about that?
Yeah, we're actually, for the next couple of months, we're actually going to extend this polytunnel and take it back against the distillery wall, and we're going to put in vertical systems in there so we can feed from the top and see if we can start doing some sort of, on a smaller scale, herbs and things that we use for next door. Try a little bit of vertical farming. We had something going beforehand with a little solar pump that pumped from the top and reticulated down through. We've actually got a gardener now that helps us do that, because before it was myself and my wife, but we've been so busy building everything, and every time we went in there, after about a week, you'd walk in and go, it's all burnt, it's all a bit dead.
Slightly industrial scale.
Yeah, that's it.
If I can just come in on that as well, you might want to talk to Henry Chryson at whatever the Agronomy Institute's called now. I don't know it anyway, but basically at UHI, because they're putting in some vertical farm, very small hydroponic units, or they look like it anyway. So he was talking about the Science Festival a couple of weeks ago, so I'm sure he'd be happy to share experience or where that's all going, so that could be a good link as well.
Yeah, I mean, the whole thing for us was for the outside area, which is going to have raised beds with vegetables and things growing, it's just here, so it's quite easy to grow it. And
could I just ask a question now on to Gareth? You were talking about the disposal, and I'm not sure I quite got the numbers right in my head. You were saying you're putting 1.2 tonnes in the front end, so and I'm not sure what that's made up of. How much of that is liquid? How much of it is solids? Or is it all solids? It's about 1.2 tonnes, looking at the sort of initial mass balance we've got going, 1.2 tonnes of grain. Okay. But brewer's grain, a little bit of mixed. Yeah. Only on a much smaller scale, probably 90% grain, 10% of other bits and pieces. You've got about 0.2, so 200 litres of water going in there as well, which is screw fed into the gas chamber, into the chamber where it's digested. Obviously, it's got to be inoculated with good bacteria. And then, as that's going through into the membrane and creating its gas, at the back end, you're starting to get the fertiliser at the back end, which, looking at the initial mass balance, going to be between 1 to 1.5 tonnes a day. And that's this basically liquor that you get out. Yeah. Okay, so and what sort of water content is that? Have you know? It's quite sort of treacly, so it's probably in terms of a viscosity, it's probably sort of 67% viscous, but it could be mixed then into permastores or whatever, or watered down and sprayed on the land. Deerness Marmite, you never know. That's it, yeah. Or Deerness Vegemite. Vegemite, of course. Sorry, let's not start that one. Gareth, do you want to take?
This question maybe fuses your present life with your old life, in the commercial world, if you like. And, I mean, this is fantastic, and there have been attempts at AD stuff previously in Orkney. With where the technology is and what you've learned from what you've done, do you think this could be replicated, across Orkney, either at this scale or are there other scales that might be more appropriate for other places? So just your thoughts on, could we have 100 similar plants or 10 bigger plants? What would, if you could look ahead 5 or 10 years and say, where could this technology be making a contribution to our energy? What would be your foresight in that?
Yeah, good question. Obviously, you know, England, other countries, people are growing crop just to feed digesters, which is quite lucrative for some of the farmers. You know, there's probably that potential here as well in Orkney. You know, if you look out across some of the fields here, there'll be a lot of green fields with nothing growing in them, so there's potential to put, you know, that sort of projects on an island to grow. You could have a mixed, you know, you've got your whole garden waste at the front end. So on previous projects from a more of my background, some of the projects I worked on were 175,000 tonne per annum projects where the refuse lorry and nothing was source separated, so there was no, you know, this bin for that, this bin for this, everything was put into one bin. So everyone had 1 or 2 bins outside the house rather than where we are now. Went into the front feedstock, the trucks tipped onto the floor, up into conveyor belts. All the sort of dangerous things, batteries, gas bottles, were taken off by people at the front end, and then it went into the project, into the plant, and then it was completely source separated mechanically. So wind sifters, eddy, non-ferrous and eddy separators. We had plastic lines, paper lines, everything was taken off. So 75% of all the municipal waste that went in the front door became a product. And then the 25% of the stuff that was, you know, not product went to landfill. So a good way of reducing your landfill. Obviously, it's got problems with that. You see, you've got all the green waste dropped into huge percolators. So the percolators then basically big rake arms spinning this stuff. All the green waste, all your garden waste, was spun over with water in there, basically getting all of the sort of energy out of the green waste, which became a liquid that went through into digester, and then the digester would be inoculated, producing gas. Out the back end came about 4 megawatts. So I did this big one in Sydney for Sydney Waste, for Blacktown, and then, as I said at the start there, we did 2 big ones for Lancashire County Council. Obviously, places in the UK, in England, have got probably a lot more shortages in landfill than we have in some of the places in Scotland. But I suppose the whole country now is really looking at all of that sort of thing. So yeah, you could scale that up to here. I had an idea. I think I've spoken to yourself before at the start there. You know, you've got all these cruise liners coming into Orkney. They obviously have to go somewhere to dump their septic tanks. But if you could find out that, you know, that cruise liner costs him £10,000 to dump his tank, we'll say to him, you can do it in Orkney for £5,000, and you could say tourist poo powers Orkney, you know, something like that. But yeah, I think it's a good technology. It's there. It's much more advanced than it was. So I'm talking 2007, 2008, when I was working on some of these bigger projects. The technology now is, like most things, has gone further than that now. So yeah, there's definitely
Yeah, sorry, just a quick question on the gas quality. You were saying when you put in different product into it, like you're okay with your dark grains, it's pretty stable, but when you start adding other things, how do you control that quality of the gas? Is there a control, or do you just, it may burn slower, it may burn hotter, but you just live with that, or is there a way that you can control that?
Yeah, so I think at the start when I was talking to somebody else in here, yourself, wasn't it? Yeah, we're talking about feedstock. So obviously with the brewer's grains, you're going to have that constant metres cubed of biogas produced. If you start adding in other waste, especially seasonal waste, you could actually probably drag those figures down. So if you start putting too much mixed waste in, so there's obviously seaweed off the beach, things like that, you know, old anaerobic seaweed, things like that could go in there as well. But that might impact your output at the back end. So we are looking at, so we've been giving waste analysis, so we've got our brewer's grains down there, we've been taking samples from the kitchens and some of the stuff that comes out of the polytunnel. At the moment we compost a lot of the stuff that comes out of the polytunnel. We don't compost the food scraps because you know, there was vermin and things around the place as well, especially with breads and food scraps and things. But if they go into the biogas plant, they're secure in there. That can affect your gas flow, so we're just looking at what, if we had a snapshot of what we were going to produce, you know, if we started going around the farms and chucking in green waste from everywhere else, it might have an impact on our output at the back end, and we'll see a decline on the turbine.
I think from Gareth's point there, if we had to get several plants, what you would want to do, of course, would we have a sort of the same plant multiplying, wouldn't you, to difficult online, I'll repeat the question, but following on Gareth's point, you would want this sort of to modularise that. You would want the same plant across the islands, just so that you've got the spares, you've got that modularity so that you can replicate that, so you don't have to have 16 different types of spares or 16 different types of things. You'd want that to be the same plant, running different waste streams, I guess.
Got commonality across the projects, and you can, if someone breaks down, you can swap in whatever.
So whether that's tourist poo or whiskey grain, it would be a different microbe only. Yeah.
I think on that first slide that I had there, gives you sort of an idea on the. Just get that back on a second. So you can see there, stop that noise. In terms of farm manure, there 20 to 80 metres cubed of fresh green waste, and then brewer's grains is right up here in terms of its output. But if you start mixing some of this into here, that'll bring that down in terms of its biogas output. This is the problem we had on these big plants is, 175,000 tonnes of stuff coming in, not all green waste, but we had some interesting things coming through. We had a shark through one day. This is Australia, obviously. Lots of money, lots of things like that. There were drug drops and things. But we had very much seasonal waste. So during the summertime, very, very high sugar contents with all the green grass and all the cuttings off all the trees and everything else, which then impacted the percolation system and the digestion system, because you got quite high concentrates of sugars going through. They start to crystallise in the pipes, so you had pipes getting blocked with crystallisation. So as soon as you start introducing, very sort of sugary, very sort of green things, that can knock on different problems. So the plant we did was a £175 million project, but every sort of 2 months it was different outputs, because you had different waste going through, and depending on what there was a purge on certain videotape and things like that, and then the next day, for the next 2 weeks, the whole place was just bunged up with videotape. So it's quite interesting, the whole feedstock and analysis of what goes in the front end impacts on what comes out the back end, like anything else.
Yeah, quick question on the, you've got like a continuous flow process for generating biogas. You've got a bladder, so you've got limited storage. What happens if you generate far too much?
Yeah, so if you generate too much, then it would have to be vented, or you have to flare it.
Is that going to be a problem though with environmental regulations as it goes in the future?
Potentially, yeah. Again, that's another one we haven't really got to that point yet of looking at all that. Initial discussions with in terms of emission, this size of plant actually sits right at the very, very lowest point of emission control.
Right.
Obviously, the bigger you go, the more regulatory requirements you get into.
Yes, sure.
How you doing?
Not bad, thanks. Great presentation.
Thank you.
How much are you engaged with the supply chain in terms of plant suppliers, and how are you finding it? Is it a narrow market where there's only a small number of people that are engaging in micro-ED, or is it quite a widespread option of choice you have?
Yeah, there seems to be there's two sort of front runners in the UK that are doing that, but in other parts of the world, it's quite much more advanced. So we've been speaking to the two ones in the UK, and they've got things from just doing this, but also covering huge pits with straw, hay, silo, and all that sort of thing. So lots of different options, not just feeding something in the front end of a small, you can cover a whole farm floor with stuff and pack it underneath, put a membrane over the top. So quite a lot of different technologies around this. So we've got about 3 or 4 companies we've gone out with some interest to, and they've sent us back some literature. So we've been trying to get some, I think it's Anaerobic Distillery that has got a small biogas plant on site, and they use their brewer's grain plus farm waste and farm scraps into that. They're a much bigger distillery than us. They're producing, they're not off-grid, but I think it's about a quarter to a half of their energy is from their biogas plant. But definitely we've been speaking to some of the ones in China, as I was telling you about, and although there's some pitfalls, as you know, in those sort of places, but they're quite a lot advanced as well in terms of technology there. A lot of the kit next door, you can have a walk up the corridor and have a look what's in there. It's a British company that's put our gear in, but most of the stuff's been made in China, like most things are nowadays, unfortunately. But yeah. We're happy to share any information on some of the vendors that we're looking at.
Just out of interest, someone told me recently that on a very different scale, of course, that Glenmorangie are now doing AD.
Are they?
I don't think they're doing CHP. I think they're just feeding the gas straight into heating the stills. Anyway, if everyone can reduce their energy input that way, it seems like a no-brainer. What I was going to ask is, you mentioned the potential for community concerns around what you're doing, and obviously I'm not asking for names or anything, but have you had any significant issues in that area?
Not so far, no. I mean,
great.
Yeah. Don't know if Sid's got anything to say.
Just get on the bottom of every company.
Yeah.
Just a little point on the excess gas side of things. I suspect you'll probably need to have a flare, but just a small one, which is a small pilot, just really as a means to get rid of excess gas if you are getting excess. Because I'm sure the regulations are coming that will prevent you from just venting methane because of its greenhouse gas performance. And the other thing is, I would urge you to make sure you got your lightning protection sorted, because obviously that's something that, from an EMIMechE point of view, we didn't have lightning protection when the hydrogen plant was put in at the start.
Okay.
We weren't, that wasn't something we were advised to put in, but subsequently during risk assessments we put it all in. So just worth thinking that through, making sure that's included in whatever offer comes up.
Great. I mean, in terms of, I don't know where Orkney is at the moment in terms of export into the current grid. Obviously there's no more turbines going onto the grid and things like that, so with the new line going in eventually, if it gets past its hurdles it's got as well, there's potential to put that back into the grid, I suppose, in the future.
Oh, that's in the gift of SSE, so who on earth knows?
Yeah. Yeah. You've also got the potential, obviously, there's, if there's excess biogas, there's biogas tractors, you could have a forklift that's LPG running on a biogas, so there's lots of other options there as well. Australia's got quite a lot of LPG converted cars. There are biogas vehicles about as well.
Yeah, just another bit of anecdote from the past about the idea of taking cruise liner poo, if you like it, or whatever it was said. There was some work done a number of years ago on agricultural waste, and there was an idea, it happens in other places, where you take sewage and you dry it off and you spread it on the fields as a perfectly good fertiliser, but there was a huge resistance in Orkney against that idea because of the quality of the cattle and stuff, and the whole perception of quality beef and quality sheep, etc. So just a slight warning around that, of not presenting too much of that piece, because I was a director of Orkney Meat for a while when it was still going, and we looked at anaerobic digestion for the blood waste particularly, and putting blood into it. And I know Colin Ridgebridger looked at that when he was doing the the biodigester in Westry was the same. And I think you just got to be quite careful of that output element, or it's not a fertiliser, you're ending up with a waste yourself. If people won't use it for fertiliser, if there's any perception, it's probably not particularly true, but because it happens other places, but there was a big resistance against that because of our quality image.
Yeah. I mean, if you had, obviously you've got brewers' grains and just green waste, there's probably an element that you get that analysed, and that should be fine for the food, but or for the land. Like you say, if you start introducing, meats and old meats and things like that go in there, then that potentially has a different effect on the output of the back end. Yeah.
Just to corroborate that point, it'll be a lot easier if you keep the waste streams very clear. Mixing in municipal waste in whatever forms turns into a nightmare, because there's goodness knows what's in the sewage sludge at any given point, because there's drugs and depending what's going on, sort of material that passes through humans. So just be careful about that bit. Yeah.
I know when we did the big project in Sydney, we had a huge composting hall. So once it had been through percolation, obviously you pulled all the energy, or most of the energy, out of the grass and the green waste. That then went through and got laid out in huge furrows in a massive compost hall, which is like 10, 12 times the size of market stands. And it had a huge overhead gantry crane that had an auger that ran up, and each day it pulled it across, and you've got this just being sucked through with air as well through the floor. So by the time we got to the end, it pasteurised effectively, so all of the bad stuff in there had gone. That then, you've got before that you've got all the hypodermic needles and all the medical waste that went into the bins and everything else out of the way. You still got the potential for metals, lead, mercuries, things like that, but then that would go through and then become compost effectively, but not really used much in the sort of public side of things, more on the sort of land abatement type sort of stuff, reshaping land and things, and then putting soils on top, so you had the potential for all those other bits and pieces to be lower.
Any other questions? So, Sydney, was that a question? Oh. Sorry, there was a small discussion at the back here on their own. Sorry, you finished? Right, any more questions? No. In that case, I'll come through this running. Just say, Stuart, thank you very much indeed for explaining where you're going and what's happening. It sounds very exciting, and Orkney likes pioneers, so we wish you all the best with all this lot. Jordan has given his details in on the chat, so we can make sure you get that for the link with ICNZ. Hope that's useful.
Thank you, Jordan.
And if there's anything else that comes up, because this recording will be put up on the ORF website, and if other people do want to get in touch, we'll make sure that Stuart's contact details or the distillery's details are available for anybody watching this at a later date if they want to get in touch. Thank you all very much indeed for coming out to the Far East, as we call it, from the West Mainlands. Thanks, Stuart, for hosting us this evening, and really wish you all the best with everything with the distillery. Thank you. Cheers.